Okay, I'm going to do, from tonight's homework, Binomial Series Basic, Problem 5. All right, so the goal of this problem is, to compute T3 of x, the third degree Taylor polynomial for 1 plus x to the negative 4. I guess you could think of it as, we've been doing this a lot, calling it f of x. So for the function f of x equals 1 plus x to the negative 4 centered at c equals 0. Okay, so that's how you've seen these things worded. So we're going to compute the third degree Taylor polynomial for f of x equals 1 plus x to the negative 4. Is that right? Yes. Centered at c equals 0. All right, so that's what we're doing. All right, so the general formula for the binomial series right, that's it. 0. Okay. All right. So you don't have to really even know what this is just yet to figure out kind of what you have to do, or to write out the first few terms of this infinite series. Right? So we'll talk about that thing in just a little bit. All right, so first things first, so let's just write out the first few terms. All right, you got k. So k is a constant. We start at n equals 0. Okay, so this right here, this is my third degree. Highest power of x is 3. Taylor polynomial, my third degree Taylor polynomial. That's what we're trying to find for the specific example where k is negative 4, and we want to make these into numbers. All right, so you might say, how do we get this? Mathematicians figured this out. Most of you are engineers. You're going to use these things to approximate numbers and stuff like that. And remember, this thing matches this thing really well, close to x equals 0. Okay. Right. So that's kind of the idea, the background. All right. So now let's do this problem. Okay. So I'll move this over here now. I'll put approximately, because this thing is equal when we have ... forever, going on forever like this. Right? That's the series. This thing converges to this. But when we just have the third degree Taylor polynomial, this is just an approximation. It's a very good approximation, close to 0. Okay, x is 0 is 1. We'll just leave that out. We got k1 x plus all right, so what we're concerned about, or what we want to find, is 1 plus x to the negative 4. Okay, so this negative 4 is acting like the k there. So we've got negative 4 and 0 plus negative 4 and 1 x plus negative 4 and a 2, negative 4 and a 3. Okay. Whew. All right, so this should motivate that we want to figure out what these things are, the binomial coefficients. All right. Okay, we figure those things out using the following formula. Okay, k n equals. All right, we have this formula in the notes and learning goals. Okay, we've got k minus 1, k minus 2. All right, what this basically means is you just keep decrementing by 1 until you get to this number here. What number is that? That number is k minus n plus 1. And all of this over n factorial. Okay, this might look really familiar to a formula you've seen for k choose n, for if you've taken discrete math, or if you're going to take discrete math, you'll see this. If you're taking discrete math from me, you'll see this in a week, or by the end of this week, actually. Statistics, you've probably seen a formula similar to this. All right, so this is a generalization. The one that you use in statistics, the one that you use in a Math 361 class, statistics class, probability class, the one that you use in discrete math is only for positive integers or 0. This one is generalized to, you can have k be a fraction. It can also be negative numbers like we have here. Okay, so this is consistent with other formulas, but it's a general form for that. All right, so now we'll figure out what these binomial coefficients are. Okay, so we've got negative 4 and a 0, negative 4 and a 1, negative 4 and a 2, negative 4 and a 3. Okay, this is 1. Why is it 1? Because we decided that's what it should be. All right, we decided that this should be 1 because if it's not 1, then all of our formulas break down. So we make this into a 1. Okay, and it works. All right, if it works, that's what works for us. All right, so we'll start using the formula with this one. Anytime you have a 0 in this spot, the answer is immediately 1. Okay, so we'll have 1 factorial. Oops, I did that last time. 1 factorial there. Okay, and so notice we start at negative 4. And now the question is, we go negative 4 minus 1, negative 4 minus 2. And we just keep doing that until we get down to this number here. So the question is, what is this number here? So k minus n plus 1. Okay, I'm going to write this like this. We're going to figure out where we stop. Okay, k is negative 4. Okay, that's negative 4. N, let's see, n is 1. So you can see that's negative 4 minus 1 plus 1, so that's negative 4. So we do this same sort of thing until we get to negative 4. But look, we're already at negative 4, right? So that means that this is negative 4 over 1 factorial, otherwise known as negative 4. Okay. So we got 2 factorial. N in this case is 2, so we put a 2 in there. Let's see, negative 4 minus 2, that's negative 6. Negative 6 plus 1 is negative 5. So we start at negative 4, then we go to negative 4 minus 1. Negative 4 minus 1 is negative 5. and that's where we stop. That's because we figured out where we stopped there. Okay. So let's see, 5 times 4 is 20. Negative times a negative is a positive. Got 2 on the bottom, so you got 10 like so. 3 factorial. Okay, now we just got to figure out where we stop. Okay, so negative 4, and negative 3. Negative 4 minus 3 is a negative 7. Negative 7 plus 1 is negative 6. Okay, so we start at negative 4. That's like k. We go to negative 4 minus 1. That's negative 5. Negative 4 minus 1 again. We get to negative 6. We know that's where we stop because I computed it right there. Okay. All right, this is 3 factorial is 3 times 2 times 1, so that's a 6. So 5 times 4 is 20, right? Negative times negative is positive, so we got 20 times negative 6, negative 20. All right, so remember from before, we had 1 plus x to the negative 4 was, oh, that's right, it was negative 4 and a 0 plus negative 4 and a 1, x plus negative 4 and a 2, x squared plus negative 4 and a 3, x cubed. So we just found all these things. Remember, this is always a 1. Negative 4, the binomial coefficient to negative 4 or 1. Let's see, this is a negative 4x, negative 4 and a 2. We got 10 plus 10x squared plus, let's see, that one we found to be negative 20. X cubed. So our final answer, 1 plus x to the negative 4 is approximately, remember it's approximately, 1 minus 4x plus 10x squared minus 20x cubed. And that's problem 5.